joining us on our webinar, What are number bonds and how best to teach them? So, what are number bonds and why do they matter? So, at its simplest, number bonds are a pair of numbers or a mixture of pairs of numbers that add together to make a specific number. So, for example, 8 and 2, that's a number bond to 10. So is 6 and 4, 7 and 3, so on and so forth. The greater a number is, the more number bonds it has. So 20 has more number bonds than 10 does, and 10 has more number bonds than 5 does. Having fluent recall of number bonds up to 10 in particular allows children to perform more advanced arithmetic, like adding and subtracting using the column method, or better yet, being able to add and subtract and do bridging over 10 and over 100, and then as they develop over 1,000 mentally, as well as using the column method. So yeah, for example, here, if we have 24 add 8, children having number bonds will allow them to add 24 and 6 together to make 30, and then realize 6 is 2 less than 8, and then add the 2 on at the end. So then we get the 32. Number bonds are quite heavily featured in the national curriculum in Key Stage 1. So it's stated that by the end of year 2, they need to know number bonds to 20 and have a grounding with that within both addition and subtraction and in their place value knowledge. And the purpose of this is to allow for that fluency which we discussed on the previous slide, where children can bridge tens and then latterly bridge hundreds and thousands as they progress through their mathematical learning. So in year 1, it's a statutory requirement that children can use number bonds and related subtraction facts within 20. That's the thing, although this webinar will focus on bonds to 5, 10, 20 and 100, the national curriculum states that children should know number bonds to, let's say, 17. So they should know that 8 and 9, 11 and 6, 12 and 15. These should be known, 12 and 5. These should be known facts for children in the same way that those 7 and 3, 4 and 6, 5 and 5, the 10 should be the same. So another point here is that it's in the non-statutory guidance, is that we should be also building those sort of fact families around number bonds, so that a child will know that 11 add 9 is 20, but also 20 subtract 9 is 11. And as well as that, throughout this webinar, you'll see that I advocate and MathShed advocates for the fact that children should be shown that the number sentence can go on either side of the equals symbol, showing some of that procedural variation, but also showing that it doesn't matter if 9 and 7 are one way around or 7 and 9, there's still a number bond to 16 too. Right, so kind of like the elemental beginnings of number bonds are your number bonds to 5, and particularly using 5 frames, which you might be familiar with. So this is a standard 5 frame, and these are great for showing facts. Like here, we would show 0 add 5 equals 5. Here, 1 add 4 equals 5. Here, 2 add 3 equals 5. 3 add 2 equals 5. 4 add 1 equals 5. And 5 add 0 equals 5. Clearly, we want children to be able to see that on the top line, on the right here, that is 1 and 4 or 4 and 1. And it doesn't matter if the 4 refers to yellow counters, or here in the bottom left, if it refers to red counters, that 4 and 1 equals 5. And that is the same as 1 add 4 equals 5, which is also the same as 5 equals 1 add 4, which is also the same as 5 equals 4 add 1. Another helpful set frame resource to use for bonds to 5 is the Hungarian Fireframe. And it builds, I think, more on subitizing that children should be doing in early number as well. So here, this could represent any of these number sentences, that 2 add 3 equals 5, 5 equals 2 add 3, 3 add 2 equals 5, 5 equals 3 add 2. As well, you could show it like this, or you could have pre-prepared frames like this, whether that's on a worksheet, whether that is set up physically on a tough tray or any other way of setting it up, to have children placing the yellow counters to prove these number sentences, for example. And here, as the national curriculum states, it's important to also include where 0 is one of the addends in number sentences, so that children begin to understand that 0 represents nothing. Okay, so here, moving on, rather than 5 frames, we're now looking at 10 frames, regardless of what the title says here. So like 5 frames, 10 frames also provide a fixed format for children to decompose and compose numbers. Okay, if you can find them, the egg cartons that hold 10 eggs are really helpful to use concrete resources. So here, we've got the standard 5 frame with 8 red counters and 2 yellow counters. And then we can also show that using cubes in an egg carton, for example, 8 and 2. And it's important here, when we are using 10 frames, that we show children both the sort of counting in 2, going along in columns method, as we've done with the standard 10 frame, but also to show filling 5 first and then adding more on afterwards, such as has been done in the egg cartons with the cubes, for that procedural and conceptual variation. So here we've got 8 add 2 equals 10, 10 equals 8 add 2, 2 add 2, 2 add 8 equals 10, and 10 equals 2 add 8, showing the commutative property of addition, that it doesn't matter which way around you put them, and also really hammering home that point about the equal symbol being anywhere within the number sentence, whether it's the number sentence comes first and the sum comes afterwards, or the other way around, it doesn't matter. Right, so number tiles, numicon shapes. These are a great way to teach number bonds to 10 or to 20. You can have 2 10s stacked onto each other, like that, I mean. And you can either have a template like this that we have. You could trace it and then photocopy a whole load of them, or you could draw them on a desktop, or you could have them drawn into a tough tray, however you want to do it. It's just really good. It helps children with that kind of spatial sense of, okay, each of those squares with the circle in it is worth 1. There are 10 of these. It builds on that familiarity of a 10 frame, because it looks very similar to a 10 frame. And then they would be able to overlay. So here we have a 9 piece, and then they go, okay, so 10 equals 9. And what other piece do I need to put down? Okay, a 1 piece. So 9 add 1 equals 10, 10 equals 9 add 1, 1 add 9 equals 10, 10 equals 1 add 9. So number tiles, the way that they have been designed, a 10 piece is equal in weight to 10 1 pieces. So if you have a 10 piece on one side of the pan balance, and a 7 and a 3, let's say, on the other side, it will show a balanced pan balance. So here we have a pan balance set up with the equal sign, and we've got 10 piece on one side of the pan balance, and then an 8 and a 2 piece on the other side, and they're perfectly balanced. And you could do this in your classroom with your pupils. So here we've got 8 add 2 equals 10, 10 equals 8 add 2, 2 add 8 equals 10, and 10 equals 2 add 8. Right, so you don't just have to use number tiles for this. You could also use multi-link cubes, because Similarly, a multi-link cube is going to be equal in weight to another multi-link cube, regardless of the color or what have you. So here we're doing bonds to 5 again. So we've got 2 and 3 on one side and 5 on the other side. And then we could explore. We could remove a yellow and swap it for a red, and then we've got 4 and 1 again. We could have 5 red and 5 orange on the other side and explore and prove all of the number bonds. So again, 2 add 3 equals 5, 5 equals 2 add 3, 3 add 2 equals 5, and 5 equals 3 add 2. Right. Now, a key structure that's used in the Singapore maths curriculum and their textbooks, from which our mastery curriculum that we use in the UK is derived, is the part-whole model. Here, we can see it's partially completed, and this image here is illustrating having a printed or drawn out part-whole model, but then with physical counters for children to manipulate and explore. So we've got 5 counters in the whole section of the part-whole model, and we have 1 counter in one of the parts. So how many more are we going to need in the other part? Going to need 4 more yellow. So then we have 1 add 4 equals 5, 5 equals 1 add 4, 4 add 1 equals 5, 5 equals 4 add 1. So here, again, similar to the previous example, children could then explore. They could take the 1 off of the red part and put 2 reds to start off with, or they could have none, and then they'd need to have 5 yellows in the yellow part. You could change the colors and explore. Does it matter if it's yellow, blue, and green, blue, red, and purple? Explore. Doesn't matter. Okay, so then with this mastery style learning, we would then progress from a concrete representation to a pictorial representation. So perhaps you would have something set out like this. It could be counters, it could be like 1 pieces of base 10 or Dean's pieces that you could have. It could be straws and straw bundles of 5 that you could be looking at. So here we've drawn a 5 tile and a 2 tile. So what would the other tile need to be in the other part to make 5? Of course, again, we're going to have 2 add 3 equals 5, 5 equals 2 add 3, 3 add 2 equals 5, 5 equals 3 add 2. You could draw a load of these and then have kids draw there to complete it, or you could just have a 5 piece and then children would have no scaffolding, no kind of beginning of a worked example, and have to do that more independently. Up to you, that's how you could differentiate it with your class. So then this is perhaps the more familiar use of the part-whole model, is to use it in its abstract form. So using numbers alone, not a pictorial representation of equipment or equipment itself. And again, we don't just have to use this for bonds to 5 or to 10 or even to 20. We could use this for 16 and then have 9 add 7 or what have you. And then 16 minus 7, subtract 7 equals 9. But here we're showing it as a bond to 20. So we've got 20 and 14. So what's the other part going to be? Of course, it's going to be 6. And then we can represent all of our addition number sentences here. You could extend children by asking them, okay, what subtraction facts can we derive from this, and see what sort of responses you get. Now, a really fantastic resource is questionnaire rods, something to build into classroom practice such that children are like fluent with using them, so that they know, say you have a set like this one, that the orange piece is the 10 piece and the white piece is the 1 piece, so on and so forth. And they're really good because if you're going to be using bar models with your classes, they work as like a concrete precursor to using bar models. And given the set values of the questionnaire rods, they lend themselves really well to number bonds teaching in particular, as well as addition and subtraction fact families, which again, the DFE wants to see us building in all as one process and project. So here we have the yellow piece, which is the 5 piece again. So we're going to be looking at a bond to 5. And say, for example, we started off with the white 1 piece. What other piece are we going to have to use? Okay, it's going to be the purple 4 piece, which means that we know that 1 add 4 equals 5, 5 equals 1 add 4, equally 4 add 1 equals 5, and 5 equals 4 add 1. Yet again, you could then challenge children to write as many addition and subtraction sentences, and they could show you even writing subtraction sentences with the number sentence and the difference written on either side of the equal symbol. So bar models are really fantastic for teaching number bonds as well. So here we have a 3 and a 7. So of course that's going to be representing 10. So that's why 10 goes into our totals bar here. And then of course we can go through and write the number sentences, challenging children again, can they write the equivalent subtraction sentences as well as the addition sentences that we have here. Number tracks are a really fantastic way to conceptualize number bonds. So you could show a number track to 10, for example, and you could shade 4 in, and then you could ask children, okay, so I've shaded 4 in, how many do I need to shade in until I've shaded in all 10 pieces or all 10 cells? And here we have 4, and then of course we'd need to shade in these other ones here, and that is 6 more, and then it makes 10. So then we know that 4 add 6 equals 10, and 10 equals 4 add 6. Right, so then really we want to progress onto using bonds to 100. To start off with, you probably want to rely immediately on those bonds to 10 and extend that so that then they would know if 2 and 8 is 10, then 20 and 80 is going to be 100. So that's represented here. And then we could then move on to shading in individual cells. And then we would have here 21 and 79 is a bond to 100. So really, for me, I think that these 100 grids alongside number lines are the best way that we can represent bonds to 100 to build on that knowledge that we have of the bonds to 10 and then moving on to bonds to 100. I think they really help with that. So here, this is a video I would recommend to track down. It will be embedded into this PowerPoint after this is sent out after the webinar. So here it shows that having that knowledge of bonds to 10 and then to 100 and to 1,000 is really helpful with rounding, but you can also see how it would be helpful for bridging as well, and that having that sort of empty number line or partly completed number line lends itself really well to that. So I'm going to skip past that. You can watch that in your own time. Okay, so here we have some investigation prompts like this, number bonds. So the greater a number is, the more number bonds it has. Is that true or false? A number can have more number bonds than the number itself is worth. Is this statement sometimes, always, or never true? If a number itself is used in a bond, the other number is 0. Is this statement always, sometimes, or never true? Spoiler alert, it's always true. So for example, 5 adds 0 is 5, 10 adds 0 is 10. An odd number has fewer number bonds than an even number. Is this statement always, sometimes, or never true? Here we could look at, 11 has more number bonds than 8, but then 22 has more number bonds than 11. So it's just an opportunity to have children using lots of number bonds, just a really a cloaked way to have children doing lots of fluency practice there. Even numbers have an even amount of number bonds. Is this statement sometimes, always, or never true? Okay, so here I will now pass over to my dear colleagues who will show you more of our games that will help children learn these bonds to 10, 20, and 100.
Okay, right, I'll get my video on for a moment. There we go. I'll just show you our fluency tools that we've got on MathShed that will help children learn these things. So this is what the teacher hub would look like if you haven't seen this already. And you can give children certain work. So within MathShed, we've got a quiz that goes with each of the lessons that they can use to practice that specific skill. And we also have fluency skills such as number bonds, times tables, adding, subtracting, and things like that. So you can see here that I've assigned a number bonds activity. So if I click details, I can see who has done that activity and what they've scored, how many they've got correct, how many times they've played it, and so on. I'll just show you some other data that's generated, and then what I'll do is I'll log in as the pupil so you can see what it looks like from their point of view if they've got this work assigned to them. So what you can also do is if you go into maths data, and I have a look at our fluency games here. So if I click number bonds, for instance, which I played earlier, you can see that it comes up with a bit of a graph showing the average time per correct answer in seconds. So you can see this is a bit of a strange one. I've used this as a test account to play for these webinars. So you can see they've actually not doing the best, need to have a little bit more practice for that to then go down. You can then see sort of total answers over time and their actual answers that they have given. So we've got a few different bits of data. I'd say the assignment data was the main thing teachers use just to check that children are practicing these at home for homework, if that's what you've set. So what I'll do next is I will log out and log in as a child so you can see what it looks like from their game screen. So here I've obviously got access to all of the different things, but if you just have MathShed subscription, that's what we'll show. And you can see all the different assignments that have been set for me here. Now, if I click on the number bonds ones, and here I've assigned myself number bonds to 10, mixed addition and subtraction, I can then click play. And the child has got the option of 3 types of difficulty. So easy, it gives multiple choice. And then medium gives 6 multiple choice rather than 3. And then for hard, I have the option to write the answer like that. So that's what it looks like from a child's point of view. The way I've got this screen is if I go, instead of clicking from my assignment there, is if I actually click into MathShed. And then from here as well, I can show you the other fluency skills that you can assign. So if you don't want children to have access to everything, so these options underneath here, when you click give them the assignment, there's a button to switch so they can literally just see what the teacher has assigned, which are those 3 icons there. But just for the reference of today, I know we're talking about number bonds. Here are all the different ones that you can assign or play. So we've got the number bonds to 10, 20, and bonds to 100. And you can choose whether you have addition and subtraction or just one or the other. So if we go to this one, for instance, that's when you can then use all of the different knowledge from number bonds to then apply them to number bonds to 100. We have other fluency skills as well, such as times tables, adding and subtracting, multiplying by tens or hundreds or thousands. And then we also have our quizzes on this side that go with our PowerPoints. So the stages are the same as the year groups, and they follow the White Rose curriculum. So there's a lesson PowerPoint that goes with each of these. So what I can do is if I click into one, and then click into a block, then I can click to a particular lesson and play the quiz from this. I'll just quickly show what that might look like so you can see. You can also get the question read aloud if you want to.
Who scored half as many goals as Chen? Input your answer like this, Oliver. Enter your answer below.
And then they write the answers. So if I just type a name. And then you can see that we've got different types of questions as well. So whether it's true or false, typing in an answer, or having a calculator to work out the answer, depending on what's right for that sort of block. We've also got end of block and end of term assessments that are in the same sort of layout. The last thing I'll show you, which also comes with MathShed, is with each lesson you get a quiz, which we just went on, but we also have a video lesson too. And these are great for consolidation or interventions or just for homework. So what they are video clips of either myself or one of my other colleagues who are also primary school trained, and as well as quizzes which go with them. So they all have the same structure, the success criteria, and then a starter explainer video.
Today we're going to learn how to make tally charts. For this starter, which one doesn't belong?
And then once they've watched that, then they can go to the next level. So you can see they have to do it in a certain order, and they'll have an explainer about our first activity.
Now we're going to complete this tally chart.
So that they know what to do.
We've got the tally here.
And once they've watched that, so they're clear on what to do and the skill which is being taught, then they will have quiz questions based on that skill. So these will look very similar to the quiz that we just clicked on. And then you as the teacher will then get all of that data and information to see whether they've completed it and how they have done. So there are quite a few different features of MathShed that you can use. You can get a free trial if you want to, whether it's a free trial for your whole school or a free trial just for you personally as the teacher, or even if you want to use this as at home as a parent. I'll just check and see if we've got any questions at all, which I don't think we do. If you have any further questions, whether it's regarding this or any subscriptions, if you email support@edshed.com and one of our lovely support team members will get back to you. I will send the recording of this. It will also be available on our YouTube channel, as well as the PowerPoint, so that you can get to the links that Alex mentioned, particularly the video, in case you want to watch that. But thanks so much for watching. I hope it was useful, and have a nice evening.